In this video, we'll be discussing Module 4, if statements. So what is the purpose of an if statement? Simple selection is a choice between two alternative paths. So in a program, you can specify a condition and determine whether you want the program to do one thing or another, depending on whether that specified condition is true or false. To put this in a real-world example, if you look at the pictures on the slide here, something we do almost every day when we leave for work or to go run errands or something, we look outside or we check the weather report and see is it raining or not, or if it's hot or cold, things like that. Depending on what we see as the answer to those questions, we prepare accordingly. If it is raining, we would bring an umbrella. If it's not raining, if it's sunny outside, then there's really no need for us to bring an umbrella. If it's cold, we might put a jacket on. If it's hot, we might put shorts on. So you can see how we make these kinds of decisions every single day. Usually we don't even really think about them. But as we learn to write if statements, we'll be thinking about it and just phrasing it in a structured way. So with the weather example, if we look outside and it's raining, then we will bring an umbrella. Otherwise, if it is not raining, then we will not bring an umbrella. So it's just taking those simple decisions and structuring them in a way that a computer can understand. Now, when we're writing conditions, we usually express those conditions with one of the operators in this list. So these are just the symbols that you will use to express a condition. So we have less than, greater than, equal to, less than or equal to, greater than or equal to, and not equal to. Only one path in the if statement will be followed, either the true side or the false side, depending on the result of the condition specified in the if clause. So here's our first if statement example. For this, the problem statement is a program is required to get a user's account balance, determine the service charge, and display the service charge to the user. An account balance less than $300 will have a service charge of $2, and an account balance that is $300 or more will have a service charge of $5. So let's look at this in Flowgorithm. So just like any program that we've designed so far, we declare our variable for account balance. We instruct the user to enter their account balance. We have input. And then we create a variable for service charge. And at the end, you can see I have it formatted to display the service charge with a $sign. So to create the if statement here, we'll click on the line after service charge. You'll see the diamond shape is the if. And when you first put it in, it's just blank. To specify the condition, you would double click on the if diamond. And then you can enter a conditional expression. So as you see in this if statement, I typed account balance because that is the variable that is storing the account balance that the user entered. And I used the less than sign because in our problem statement, you'll notice that the condition was that an account balance less than $300 will have a service charge of $2. So I specified that as my condition, less than 300. On the true side, to add in actions, you would just click on that arrow and then add whatever actions. Typically, you'll be using the same symbols that we have been using. And then on the false side, same thing. You just click on that side and add whatever actions you need to add. So in this case, I have added an assign shape so that I can assign a service charge of $2 on the true side and a service charge of $5 on the false side. So when this program runs, it will get the account balance from the user. It will check at this point to see if the account balance is less than $300. If it is, so if this condition is true, it will assign service charge equal to 2. And then when it outputs, it will display $2 as a service charge. As long as the condition is true, what is on the false side will not run at all. Conversely, if the account balance was 300 or higher, then the if statement would run what's on the false side, which is service charge equals 5, and the true side would not run at all. So it's always one or the other, depending on the results of this condition. So let's run it just to see how this works. So it says, please enter your account balance. So I'm going to enter an account balance of $250. Okay, so as it should, it determines that $250 is in fact less than $300. So it says your service charge is $2. Okay, I'll run it again, and this time I'll put in $500. It determined that $500 is greater than $300, so the condition is false. $500 is not less than $300. So the service charge is $5. And I'll run it one more time to show what happens if I put in exactly $300. So as you can see, when I type in exactly $300, it looks at this condition and it says, well, $300 is not less than $300. So it goes with the false path. Service charge is $5. So just keep in mind, again, that difference between the less than or equal to. That in this case, since we've only used the less than, 300 is not included in that. So 300 would trigger the false path to execute. Now, you don't always have to specify a false path. This is used when a task is performed only when a particular condition is true. If the condition is false, no processing is done and the if statement is bypassed. So I've adjusted our problem statement and our flowchart for that same similar scenario. So in this problem statement, a program is required to get a user's account balance, determine whether there is a service charge, and display the service charge to the user. An account balance less than $300 does not have a service charge, but an account balance that is $300 or more will have a service charge of $5. So in this case, instead of having two different service charges to choose from, the account will only have a service charge if the balance is $300 or more. So we don't really need it to take an action if the account balance is less than $300. So in this case, I've set the service charge to 0 to begin with, just so it does have a value in there. Then for account balance, for the condition, I've set account balance greater than or equal to 300. So in this case, I have included the value of 300 because it's $300 or more. If that is true, it will change the value of service charge to 5. However, if it's not true, if the account balance is less than 300, then nothing will happen. It will simply jump to the output and it will display that the service charge is 0. So let's see how that works. Let's try it out. Please enter your account balance. So first of all, I will enter an account balance of $500. Your service charge is $5. So it looked at this condition, 500 is greater than 300, so it changed the service charge from 0 to 5. I'll run it again, and this time I'll put in a value of 200. Your service charge is 0. So in this case, it looked at the condition, 200 is less than 300, so this condition is false. So nothing happened in the if statement. It simply jumped to the output. And I'll run it one more time with the exact value of 300, just to show that your service charge is $5. So just to show that if you put in the exact value, because this is greater than or equal to, it is included and this condition is true. A combined if statement contains multiple conditions connected with the keywords and or. So at times you may need to specify more than one condition to decide whether an action should be taken or not. On the left side, you'll see an example of using and. With and, both conditions must be true for the true path to execute. If either one of the conditions is false, then the false path will execute. In this case, we have a program that is required to get a student's GPA and age and determine whether they are eligible to join the Honor Society for Young College Students. To be eligible, the student must have a GPA of 3.8 or higher and be 20 years old or younger. So let's look at this example in Flowgorithm. The only real difference here in how we create this flowchart is in our if condition, we would use the and keyword and then add a secondary condition. Just remember that with the and keyword, you must have both conditions be true at the same time for the true path to execute whatever steps you've put on that side. So just make sure that you don't specify two conditions that cannot be true at the same time, because that would result in the program not running correctly. So let's run this program and we'll test out how this works. So I'm going to enter a student's GPA as being 4.0, and then I'll enter the student's age as 18. And I get the result: the student is eligible to join the Honor Society for Young College Students. And if we look back at our if statement, so the 4.0 met the condition of being greater than or equal to 3.8, and the age of 18 met the condition of student age being less than or equal to 20. So both conditions were met, and it gave us the output that the student is eligible, which is on the true side. Now let's see what happens if we run it and both of the conditions are false. So let's say they have a GPA of 3.0 and they are 22 years old. It tells us the student is not eligible. So it looked at the conditions, both were false, and it took the false path. And then finally, let's see what happens when one condition is true but the other is false. So let's say the GPA matches. It is greater than 3.8, so we'll put 4.0, and then the student's age is 22. It still says the student is not eligible, so it looked at the condition. The student GPA was greater than or equal to 3.8, but the student age was not less than or equal to 20. Because we're using the and operator, both conditions have to be true for the whole thing to be considered true. So because the student age was not less than or equal to 20, it took the false path. And one more time, let's do the GPA not being eligible, but the age being eligible. And it still tells us the student is not eligible, because even though the age met the requirement, the GPA did not. On the other hand, if we use the or operator, then only one of the conditions needs to be true. So in this example, a program is required to get a student's major and determine whether they are eligible to join the club for STEM majors. To be eligible, the student must be enrolled in the computer science major or the mathematics major. So either one of these majors will qualify them to join this club. So we have set a variable student major so that the user can input the major, and then the condition actually looks at student major twice to see if it equals either one of these values. So in Flowgrithm, once again, the only difference here is that we have used the OR keyword and added a secondary condition. This time, because we are looking at text, we put the text in quotation marks. So if the major equals either one of these values, computer science or mathematics, then the condition will be true. Because student major can only have one value at a time, we could not use the AND keyword here because you cannot have a variable with two different values at the same time. So if we were to use the AND keyword, then this would never be true because it can't be equal to computer science and be equal to mathematics at the same time. That's why we have to use the OR keyword. So we can specify two different values that are acceptable that will make this condition true. So let's test it out. So if I entered the student's major as computer science, the student is eligible. If I enter the student's major as mathematics, the student is eligible. If I enter the student's major as English, it will say the student is not eligible to join the club for STEM majors. If statements can also be nested within each other. This is useful when there are a series of conditions that you need to check. So in this problem statement, a program is required to have the user enter the current temperature and then display a message telling the user that the temperature is hot, moderate, or cold, depending on what the temperature is. So a temperature of 80 degrees or higher is hot, a temperature from 50 to 79 degrees is moderate, and a temperature under 50 degrees is cold. So looking at this example in Flowgrithm, we have our integer of current temperature. We have the user input that current temp, and then the very first thing is that it will check to see whether the current temp is greater than or equal to 80 degrees, because 80 degrees or higher is supposed to be hot. If that condition is true, then the output will be the current temperature is hot. If it is not true, then we have a second if statement. It will check to see if the current temperature is greater than or equal to 50 degrees. And then if it is, it will say the current temperature is moderate. Now you might wonder, in our problem statement, it said that a temperature from 50 to 79 degrees is moderate. So why in our if statement here do I have current temp greater than or equal to 50? I don't have anything about 79. Well, because this is a nested if statement, look at how this program will execute and the order in which it will execute. So it first checks to see if the temperature is greater than or equal to 80. If it is, then it outputs the current temperature is hot and the program ends. Nothing else on the false side will run. However, if the temperature is not greater than or equal to 80, then it takes the false path, which leads us to the second if statement, current temp greater than or equal to 50. Now at this point, the program already has checked to see if it's greater than or equal to 80. So if it makes it to this point, we already know that the temperature was not greater than or equal to 80. So that sets our upper boundary, and that way this second if statement simply needs to check and see if it is greater than or equal to 50. because it already knows that it is 79 or less. So that's just a way to simplify the processing that the computer has to do, and to make it easier for yourself as a programmer to specify these conditions. Now, if the current temperature is not greater than or equal to 50, then it will take the false path and it will check finally whether the current temperature is less than 50. If it is, then the output will be the current temperature is cold. You can also have nested if statements going the opposite direction. So in our previous example, each successive if statement was on the false side. So only if the previous if statement was false would it move on to that second if statement. In this case, we have the nested ifs on the true side. So as each condition is proved true, it checks for the next if statement. And if that one's true, it checks for the next if statement. So in this case, we have a program that is required to have a user enter a student's GPA, age, and major, and then recommend a club or society that the student is eligible to participate in. So we have a few different options here. The Honor Society requires a GPA of 3.8 or higher. The Honor Society for Young College Students would require that GPA and that the student be 20 years old or younger. The Honor Society for Young Computer Science Students requires the same GPA and age, but they also have to be enrolled in the computer science major. And then our Student Activities Club is pretty much open to anyone. There's no requirements for participation. So looking at this program in Flowgorithm, let's look at our if structure here. So again, the first thing it will do is check this condition in the first if statement. So it will check whether the GPA is greater than or equal to 3.8. Now, in our requirements for the program, you saw that the GPA being 3.8 or higher is a requirement for all three of these societies, the honor societies. So that's why we start with this GPA. If the GPA is not 3.8 or higher, then it doesn't matter whether these other conditions are true or not. So we start with the GPA. If it is not 3.8 or higher, then it automatically goes to the false side where it says the student is eligible to join the Student Activities Club because it does not have a GPA requirement. If, however, the GPA is 3.8 or higher, it will take the true path and it will check for the next condition, which is the age. If the age requirement is not met, it will recommend the Honor Society because their GPA was high enough. If the age requirement is met, it will then check to see if their major is computer science or not. If the major is not computer science, it will recommend the Honor Society for Young College Students because their GPA was high enough and their age was low enough. If the student's major is computer science, it will recommend the Honor Society for Young Computer Science Students because all the previous conditions have been met. They are all true at the same time.